Sounds
Hey,
good.
thanks for joining us here at Embedded World in the Intel booth.
Absolutely. Very excited to be here.
Absolutely. One of the big highlights this year at the show is all the interest in physical AI and robotics. Of course, Trossen, that's your focus.
Yes.
Why don't you tell us a little bit about your key products and where your focus is today?
Yeah, so we kind of sit at the nexus point of connecting hardware and software with machine learning models. So universities, researchers, engineers all over the world utilize our systems for testing out their ideas, proving out their white papers, developing new models on that. And in return, we hear back from customers as to the features that they need, the things that they're trying to accomplish that the world probably isn't going to see for another few years. What that helps us do is find consensus. The things that are maybe eccentric to one group and things that are very interesting and needed for a whole bunch of groups. And then we can continue to make hardware innovations that really reflect them and the progress they're trying to do in the physical AI space.
That's fantastic. We know one of the great areas of innovation right now is Gen AI, VLM and VLA models.
Yeah.
And I'm wondering if you could talk a little bit about how you see that technology evolving. VLAs are very popular now.
Yeah.
Many of them are still very heavyweight relative to running on robotics, but that's rapidly changing. What are you seeing?
Yeah, so if you rewind a couple of years ago, a lot of it started with ACT, or action chunking transformers. This was kind of the first model that was really great at a very core function of being able to take data input, train a model, and seeing that into a relatively successful model. Since then, they've added context and additional meta fields on top of there. So that includes LLMs, being able to contextualize particular inputs, like when I speak to you, it tokenizes it, and that creates additional weights in the neural network to be able to make better decisions. You've also seen these feedback loops like you do in OpenPy, where it can correct itself mid-task. So we've seen very rapid progress on these in the VLAs. Coming up over the next year, we're going to see VLA Plus, where they incorporate sensor information and additional layers of metadata so that overall it senses its world better. It can understand more like humans do, as well as the input modalities that allow it to have enough data to be able to do a robust set of tasks. And we kind of see generally two camps with this. We have those that are looking at the foundational models, the ones where it may be more as a service. And so if they can build a model that can do almost anything and generalize, that's an end goal for them. And then there's those that are focused very much on small finite tasks, maybe in an agentic approach, where it's a combination between traditional automation and small subtasks that it can call upon. And so right now, those are kind of, two debating, theses on what will ultimately win out, where you see physical AI deployed in the real world.
Absolutely. The other thing that I notice is the range of performance and size of those models, depending on whether you're doing a robotic arm or going for a humanoid. You have small VLA at the low end doing much simpler things.
Right.
You have Pi Zero at the higher end. How do you think that will continue to evolve? Will the spectrum continue to spread, or will things converge to a certain point?
Yeah, I think there are a few constraints here. Number one is volume of data, right? So we're kind of in an arms race to see how much data can we generate in a variety of tasks with all of those factors like lighting, position, etc., to being able to feed into these models. So for them, it's a very hungry, data pipeline to saying how much more can we get in there.
Yes.
And then on the other end, it's a lot more about optimization, saying with maybe 10 demonstrations, how much can we absolutely extract out of that? I think both of them are beneficial, right? One is just practicing a different constraint compared to the other. And ultimately, we have learnings and findings and technologies that evolve out of them that will likely come together when we do have these commercial applications to say what are best practices, and also that it being tied to ROI adds that probably the final constraint where it's like, okay, we need it to work 99.9% of the time.
Absolutely. And I think that optimization and commercialization piece really pushes the envelope towards how do you make this as practical and efficient as possible. With Intel, we recently launched our Core Ultra Series 3 processor, codenamed Panther Lake, which has almost twice the AI capabilities of our prior gen products. And that's made a lot of waves in terms of being a capable AI platform.
Right.
And we have our OpenVINO software and other software for optimizing on that. You all have recently started trying that platform. What have your experiences been?
Yes, we're very excited on this front. x86 in particular for developers and engineers is a very important architecture in that it has probably the widest adoption of developers, the earliest adoption of new updates to it, and the widest breadth of frameworks that they can use. So that's a great thing. The CPU performance is incredibly high. I mean, you're talking about high-end desktops in an embedded chip that's only 60 watts.
Yes.
Combine that with a very high performant GPU as well as the I/O that's equivalent to the Jetson systems out there, and you've got a very powerful system that's a delight to develop on. It's great in terms of compatibility, and it has the features that developers and researchers are looking for as they explore deployment options for this.
I'm glad this is a great platform for robotics developers, and you've found that to be true. When developers are just getting started in this space, what's a good place for them to start?
So, a lot of times you have to think about your end goals on here because there's a lot of steps involved that are very potentially arduous, like data collection, that you want to think through before you go and jump in the deep end. So, a lot of research into what models work for me, what development platforms work for me. Is it purely deployment, or do I have a wide range of workflows that I need to account for? And then start with your budgeting, your embodiments, whether it's a small arm or a large cobot. And then from there, you'll see things fall into place. And all that planning you did ahead of time will make it so you're not wasting time collecting 100 episodes and then you're like, man, I should have picked a different model or a different computer or a different embodiment.
What are some of the most interesting use cases for robotics that you've seen?
Yeah, so I think some of the areas that have had the most attention is going to be like things like commercial food prep, where there's an ROI already attached to it, where it's generally dexterous tasks that humans have been able to do, but they need to do it in a high volume. So that's a big area that we've seen a lot of investment in, as well as some of these more, home edge cases where they're trying to put down the groundwork now for what will be commercially viable in the consumer sector in approximately 5 to 10 years. So we've seen a lot of effort there. Where I see the most impact is probably in small to medium-sized enterprises that have very difficult to automate tasks, whether it's because it's dexterous or the cost isn't there, right? A very expensive cobot and a deployment there could be hundreds of thousands of dollars. As you start to scale these down, that's where you can see ROI on things that have never been automated before.
That's really great, and it's a wide new world out there. We're excited to keep partnering with Trossen in this space and see how robotics evolves. Thank you so much.
You're absolutely welcome.